Hello guys, welcome to another video. This will be the first episode of how to create geometry dash inside Unity. And for this episode, we're going to work on the cube game mode. Let's start off with the moving. So over here, this cube over here, this is the player. The player is 1 by 1 units. Inside a geometry dash, you have different speeds. You have slow, normal, fast, you have faster, fastest. So for slow, the number is 8.6. For normal,
10.4. For fast, 12.96. For faster, 15.6. And for fastest, 19.27.
But what do these numbers actually mean? Well, if we, for example, take 10.4, this indicates how much the player will move per second in units. So that would mean 10.4 units per second. So if the speed would be normal, if we have our player over here, it would move to the right direction with a distance of 10.4 units per second. That is basically the moving. For the jumping, there are a few things we have to do to make sure that this will work properly. First of all, the player needs to be holding the left mouse button. You have to make sure that the player is touching the ground. And then the actual jumping itself. So, how do we go about all of this? Well, for the mouse, it's pretty simple. This is just Unity's built-in input system. For checking the ground, we could use a raycast. For the jumping, we'll apply a force. Okay, let's actually implement that inside of Unity. Okay. So the first thing we're going to be doing is we're going to add the player, which will be an empty. Let's call that player. Let's reset the transform. Let's add a sprite, and we'll just call that sprite. And just go to create, and then sprite square, player sprites. Then assign that like that. Okay. So this is the player. In a later episode, we'll change the texture of the player, but for now, it's just a white square. Inside of the player, we're going to be adding a script. We'll call that movement. We're going to be adding a rigid body 2D. And we're going to be adding a box collider 2D. Set the gravity scale of the rigid body 2D to this number. The notes that I have over here, I'll put that inside of the description, and that is all the components we're going to be needing for the player. So let's get coding. Okay. Let's start off with the moving of the cube. So we discussed this at the beginning of the episode. There are different types of speeds, and they all have a value connected to them. So we'll start off with the different speeds. So for that, we'll create a new enum. Not sure. Yeah, I think. Have slow, normal, fast, faster, and fastest. These are the 5 speeds in Geometry Dash. And slow is going to be 0, normal is going to be 1, fast is going to be 2, etc. Okay, now we're going to be creating a value. We'll call that current public speed, and we'll call that current speed. Now if we save that, you can see that in the current speed, we can now pick between slow, normal, fast, faster, and fastest. But right now, they don't mean anything. So to fix that, we'll have an array of floats. We'll call it speed values. which is going to be, yeah, these ones. So as you can see, 8.6 is slow, 10.4 is normal, 12.96 is fast, etc. The array has different elements. 8.6 is element 0, 10.4 is element 1, 12.96 is element 2, 15.6 is element 3, and 19.27 is element 4. And these actually match up with the numbers we have assigned here, which match up with slow, normal, fast, faster, and fastest, making slow 8.6, normal 10.4, fast 12.96, faster 15.6, and fastest 19.27. Then every frame, we're going to be moving the player. The way we're going to be doing that is transform.position plus equals. So we're taking the current position that the player's in, and we're plussing that by vector free.right, and we'll times that by speed values, current speed. And as you can see, this is there's an error here, and it says we cannot convert type speeds to integer. So the way to fix that is by making two brackets here and typing integer inside of that. That would fix the problem, because now it would take the values that we put here. So if we put our current speed to normal, then this would be a 1, which would be 10.4. So vector free.right times 10.4. But now there's one slight problem. That is, when we go back into Unity and we start the game, the player moves insanely fast. And that is because we move the player to the right times 10.4 every single frame. So if we, for example, are on 100 FPS, then we would be moving 1040 units per second, which is not what we want. We want to move 10.4 units per second. The way to fix that is by timesing it by time.delta time. So if you would be on 10 FPS, then time.delta time would be 0.1, for example. Now if we start Unity, but you can't really see because it immediately falls, so let's make a quick ground. Call that ground. Now we'll just use the player's sprites. Let's stretch that a bit. Yep, like that, and then add a box collider 2D. Now if we run it, as you can see, the player moves. If we would move slow, then the player moves slower. If we, for example, go to fastest now, then the player moves way faster. So for the jumping, we discussed the different things we need to do to actually implement the jumping. And we started out with the mouse. So let's add that now. We'll start with an if statement. If inputs dot mouse button 0, which is the primary mouse button, which is the left mouse button, then we would jump. So next up is checking if the player is on the ground. Let's make a new function for that. We'll call it onGround. And the reason I'm saying bool instead of void is because we're going to be returning a boolean, so true or false. I'm going to say return physics 2D dots overlap circle. So we're going to be needing a point and a radius. Okay. Now let's say public transform GroundCheck transform. GroundCheck transform dot position, and let's make a new float. and we'll call that GroundCheck Radius. Besides that, we're also going to be making a public layer mask, and we'll call that ground mask. So we're going to be needing a point, a radius, so GroundCheck Radius, and a layer mask, which will be ground mask. Okay, great. That is all we need to check if the player is on the ground. Out of Unity, we're going to be making that point, so we'll call it ground check. Position will be of the Y will be -0.5. So as you can see, this is at the very edge of the player. Now we need to define everything inside of Unity. The ground check in here. Ground check radius will be 0.05. Like that. And we'll make a new ground mask. Oh, there's already one for ground. So the ground mask will be ground. So for the ground, we'll make the layer ground as well. So now we can say if on ground, we'll do something like print layer jump, like that. Now if we click, we should see layer jump pop up. But although I only click once, it appears 6 times. But if we're actually going to be implementing jumping, then the player is no longer touching the ground anymore because it's jumping up. So what we're going to be doing now is we're going to put our rigid body 2D in here. Reason we're going to be needing our rigid body 2D is because we're going to apply force. So in the start function, we'll define rigid body. Rigid body will be get component rigid body 2D. There we go. And now if the player is on the ground and we click the mouse button, then rigid body dot add force gear 2 dot up times what number? Yeah, this very big number. Oh, make sure you put an F in there. Oh yeah, I forgot. Force mode TD, yeah. We're also going to be needing the impulse force mode. Otherwise, it won't be enough force to actually jump. And now, as you can see, we can jump. Oh, one more thing. It is a good idea to get rid of all velocity before jumping. So, vector 2.0. And inside of the player, make sure at constraints over here, you freeze the X position and the Z rotation. That's it for today. I hope you enjoyed the video, and I'll see you next time.